Hello everyone and welcome back to the next lesson in our organic chemistry topic. We've covered lesson 1 and lesson 2, so today we are on lesson 3, which is properties of hydrocarbons. In this lesson, hopefully we will be able to list some of the properties of hydrocarbons, so there's some properties that you're going to have to remember, and once you can remember those properties, we're going to be able to describe those properties in relation to the length of the hydrocarbon. Before we start the new content of today's lesson, a little bit of retrieval practice. Last lesson we were looking at fractional distillation, so 2 questions about that. Pause the video now, write your answers down, and we'll check your answers in a short while. How did you do? So question 1 says the first stage of fractional distillation is that the crude oil is vaporized. What does that mean? So remember, fractional distillation is about separating the crude oil into useful substances like petrol and bitumen and diesel. So what does vaporization mean? Well, crude oil is a liquid. So if you're going to vaporize it, it means you have to heat it up until it all turns into a gas. That's the first stage of fractional distillation. And the second question says, where would long chain alkanes condense during the fractional distillation process? And why at that place? Why there? Okay, so what you remember first is that the actual separation takes place in the column, in the fractionating column. And there's a temperature gradient in there. I don't know if you remember, it's cooler at the top and it's hotter at the bottom. And the rule is that the long chain alkanes, they condense at the bottom at the higher temperatures. So at the bottom of the column is where they would condense, and the reason for that is the temperature there is hotter than at the top of the column, and the long chains have high condensation points. Well done if you got that right. If you were struggling with that, or you haven't done that lesson, maybe you need to look back at lesson 2, fractional distillation. So this phrase, properties of hydrocarbons, a lot of people get confused before we even start because they don't understand what we mean by the word property. Now the best way I can explain it is a property of something is a characteristic of it. Okay, so a property of myself is that I'm extremely good looking, of course. But if we use a better example, if we use some ice cubes, yeah? So if I give you one property of ice cubes, the one that I'm going to give you is that they are transparent. That means you can see through them. Light is allowed to travel through them, so you can see through it. So can you think of any more? Just give yourselves a few seconds. Pause the video now, see if you can write down any more properties of an ice cube, and then we'll go through a few. Okay, what did you get? So I can't check what you've written down, but I'm going to write down some for you. Okay, so the first one is ice cubes are cold. They are also very slippy. So if you have them in between your fingers, it's very easy for them to slip and slide out of your fingers. Another property would be that they melt easily. They've got very low melting point, melts at 0. Another property would be they're hard. You wouldn't want one be smashed around your head because actually it hurts. And finally, you could say that they're brittle. And what that means is if you drop them on the floor, they can smash. They smash really easily. So of course, we're not interested in the properties of ice today, we're interested in the properties of hydrocarbons. So let's just pause for a second. The hydrocarbons are the compounds that are found inside crude oil. Now, as far as the exam is concerned, they're going to want you to be able to list the three properties that all hydrocarbons have, and then later than that, they want you to look at the link between that and the length of the hydrocarbon. So let's have a look at the properties first. The first property you need to know is the boiling point. So what is a boiling point? A boiling point is the temperature that a hydrocarbon boils at. So do the long ones, do they have a high boiling point? Do the short ones, do they have a high boiling point? The second property is its flammability. Flammability is dead simple. You've probably heard that word before, flammable. And it just means how easy is it for the hydrocarbon to set on fire. So for instance, is a long one like bitumen. Is that highly flammable? Does that set on fire easily? And the final one is the one that's probably going to cause you most concern. And it's the one that you won't have heard of before. And it's this word. It's viscosity. And viscosity basically describes how easily a hydrocarbon will flow or it will run. So let me give you an example of that. This obviously isn't an example to do with hydrocarbons, but let's say I choose treacle. Okay, now treacle, if you tip it off the end of the spoon, it flows really slowly. And that would be described as having a high viscosity. If you was to observe water coming out of the tap, hopefully you would be able to compare it to treacle and know that it's going to flow really, really quickly by comparison. And that, on the other hand, therefore, would have a low viscosity. So a substance that has a high viscosity flows slowly, and a substance that has a low viscosity will flow really, really quickly. So as I said previously, it's not just good enough to be able to recall those properties. You're going to have to consider the length of the hydrocarbon and how it affects those properties. So for instance, some examples like I gave you before. Do longer hydrocarbons set on fire easier than shorter ones? Do short hydrocarbons have lower boiling points? Or do longer hydrocarbons have a high viscosity? So let's have a look at the kind of way that this information may be presented to you in an examination question. So we've got a graph, and the first thing to notice, let's explain what the graph is actually saying to us. Okay, so on the y-axis it says boiling point temperature, and right down near the origin it says minus 150, and then it goes up in 50s. So it goes minus 100, minus 50, 0, and then it goes 50, 100, and 150. So as we go from the bottom to the top, the temperature is increasing. And then on the x-axis, we've got the number of carbon atoms in the chain. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So if you've got one carbon atom in the chain, you're a short hydrocarbon, and if you've got 8, you're longer by comparison. Okay, I don't know if you've noticed on this graph here, remember when we were drawing alkanes, yeah, and we used the phrase monkeys eat peel bananas to remember methane, ethane, propane, and butane. They are 1, 2, 3, and 4. Okay, so what is the relationship then between the number of carbon atoms and the boiling point? Well, I hope you can see that as the length of the hydrocarbon increases, so as we go from 1 up to 8, the temperature also, or the boiling point, sorry, not the temperature, but the boiling point also increases. Okay, now if you wrote that in an exam to kind of describe the relationship on that graph, you would be right. But one thing that I would plead with you always to do is use examples of information in the graph. So to finish my question off, I'm going to pick out a couple of numbers. So I'm going to say that ethane, which has 2 carbons long, that boils at around minus 90. Very difficult to read it on the screen. And heptane, which has 7 carbons in it, boils at around 100. So that information that backs the point I've just made. Ethane is shorter than heptane. Heptane is longer than ethane, and therefore, as the length of the hydrocarbon increases, so does the boiling point. So a different way of presenting the information may be in a table. And this time we're talking about viscosity because we're talking about the flow. So if you look, we've got the number of carbon atoms in the hydrocarbon. It goes 8, 16, 24, 32. So 32 is the longest, and the one that has 8 is the shortest. And then what we're looking at in the other column is the time taken for 100 milliliters of that hydrocarbon to flow through a funnel. So I give you the example of the treacle flowing off the spoon. This is the hydrocarbon flowing through a funnel, and somebody is timing how long it takes. So the question that could appear on the exam might be this. It says, describe the relationship shown in the table. Use examples from the table in your answer. So pause the video now and have a go at that question, and we'll check your work in a short while. Okay, how did you do? So what is the relationship? Well, what I can see is this. If I go from 8 to 16 to 24 to 32, the length of the hydrocarbon is increasing, and the time taken for the hydrocarbon to flow is also increasing. So I've written a sentence that says, as the length of the hydrocarbon increases, so does the time taken for 100 milliliters of it to flow through the funnel. And then look, the second part of the question said, use examples from the table in your answer. So I've said it takes a hydrocarbon with 8 carbons, 6 seconds, and it takes a hydrocarbon with 32 carbons, 225 seconds. Backs up the original point that I made. Well done if you got that right. And if you didn't, don't forget to use examples. So we've got one final property to look at, and that property is flammability. So I've got 2 examples on the screen. I've got petrol, which is 8 carbons long, and I've got bitumen, which is 40 carbons long. So we know that petrol is used in cars, and bitumen is that tar-like substance that might be used in roads. So my question, which one is easiest to set on fire? And you probably know the answer is petrol. Okay, so the relationship between flammability and size is this. Actually, the shorter a hydrocarbon is, the more flammable it is. Think of monkeys eat peeled bananas. They're 1, 2, 3, and 4 long. They're the ones used in the Bunsen burners at school, and they're really easy to set on fire. Okay, well done everybody. That's the end of the lesson on properties of hydrocarbons. All that's left for me to do is to set you some work to email to your teacher. So I'm going to give you a choice. You can either create a revision poster that describes the link between the length of a hydrocarbon and its boiling point, flammability and viscosity. Or you could create a series of 15 flashcards to revise and review the organic chemistry topic that we've covered so far. Well done everybody. Choose wisely and email your work to your teacher.